Shown below is a light ray traveling in a medium with index of refraction 1.3 that enters a medium with n equals 1.2 and then another medium with n equals 1.1. Take the initial angle of incidence theta 1 to be 50 degrees. In part A of the problem, we're asked to calculate the angles theta 2 and theta 3 as the result of refraction at each of the two interfaces. Snell's law tells us that n1 sine theta 1 is equal to n2 sine theta 2. In going from a medium with index of refraction 1.3 to the second medium with index of refraction 1.2 and incident angle 50 degrees, we will get a resulting angle theta 2. The only unknown in this expression is theta 2, and we can solve for that easily to get the result 56.09 degrees. This is larger than the angle theta 1 because we have gone from the denser medium to the less dense medium. Next, we'll perform the same calculation, except this time going from medium 2 into medium 3. The index of refraction in medium 2 is 1.2. In medium 3 it's 1.1, and we know the angle theta 2 from our previous calculation, leaving our only unknown to be theta 3. Solving for theta 3, we get a result that is again larger, this time 64.87 degrees. In part B of the problem, we are asked to sketch each one of these rays. I'll follow the color of the calculation in sketching the rays, and we can see that these rays are successively bent away from the normal at each interface because we are entering media with successively less and less index of refraction. Finally, in part C of the problem, we are asked to consider a situation. While driving on an asphalt road in the heat of summer, you notice the road ahead of you appears to be wet. However, as you approach the wet area, it seems to move away from you, always remaining well ahead of your car. Explain in a few sentences, and possibly a sketch, the source of this mirage. Let's consider this black line to represent the road top, and we'll assume that you're driving a purple car. Because the road surface is hot, it will heat the air that is closest to it. As a result, very close to the road surface is the least dense air, and a little bit higher up is the most dense air. As a result, sunlight that comes in at a grazing angle will, as it experiences smaller and smaller indices of refraction, bend closer and closer to being horizontal until it eventually reflects. The result is that due to the indices of refraction being smallest at the bottom and highest at the top, anytime the light from the sun hits the road surface at a grazing angle, it may be able to reflect upward as though the road surface is like a mirror. This is exactly the kind of effect you get when the road surface is wet, and so that's why when your mind sees a reflection coming from the road surface, you imagine it to be wet. To summarize this in a sentence, we can say that at grazing angles, the less dense air at the road surface effectively becomes a mirror. And this effect that happens at any hot surface is known as a mirage. So you can see that as opposed to the Warner Brother cartoons, a mirage does appear to contain water, but not palm trees or camels.